Hello everyone, welcome to Equal To, and in this video we are going to see about the effects of change of pressure in the states of matter. So in the previous video we saw about the effects of temperature in the states of matter, and these are the two definitions that we came across in the previous video, right? One is melting point. So what is melting point? The minimum temperature at which solid melts to become a liquid at the atmospheric pressure. So this is something that we should note. I'll tell you why. Just keep this in mind. And even in the definition of latent heat of fusion, we are telling that the amount of heat energy required to change 1 kg of solid into liquid, but it is mentioned that it is at atmospheric pressure. Okay. So 1 atm. atm is what we call in short for atmospheric pressure, right? Atmosphere atm. Now, what exactly is atmospheric pressure? Okay, we know that basically the SI unit of pressure is Pascal, right? SI unit is the standard unit that we use for in science, right? In common, like we are going to make it standardized so that it's easy for us to work with. So Pascal is the SI unit of pressure, but what exactly is atmospheric pressure? So there is a simple conversion, you could say. 1 atmospheric pressure is actually 1.01 into 10 to the power of 5 pascals. So that is the exact amount of pressure which we call as atmospheric pressure or standard pressure. Okay. So when you try to simplify this, you will end up with 10 power 5 pascal itself, because it's 1.01 which you could approximately round to 1, right? And 10 power 5 Pascal is what we usually say as atmospheric pressure. So what exactly is this atmospheric pressure? The pressure that air exerts in atmosphere is atmospheric pressure. Okay, so we have already seen that the gas particles, they are randomly moving, they are randomly vibrating, they are moving fast, they have a lot of kinetic energy, and they hit the walls of the container they are held in, right? And that causes a pressure on the container. Okay, that is what we call the pressure of the gas. Now, air is a mixture of gases, right? And this air also has a lot of kinetic energy. The molecules that are present in air also has a lot of kinetic energy, and that pressure is what we call as atmospheric pressure, and this is measured at the sea level, right? Sea level is the height that we use. At that point is what we say as atmospheric pressure. That is where the pressure is 1 atmosphere, right? I hope this is clear. Atmospheric pressure is 1.01 into 10 to the power of 5 pascals, and that is the pressure exerted by air. Now, to the first question that we saw is the effects of pressure on states of matter. Okay, now we are going to do a simple example. If you take air, or if you take some liquid, and if you put it in a cylinder and a piston and try to compress it, the particles that are present in the original state will get closer to each other. That has been depicted with this diagram, right? In the first picture, you could see the particles have lot more space in between them and they have high kinetic energy, right? Now when you start pushing the piston in, the spaces between the particles are significantly reduced. They are drastically reduced, and the energy also reduces, right? The force of attraction increases because you are trying to push it in, like so. The forces, the pressure that you apply is used to bring these particles closer together, and when you're completely done with it, it's absolutely like a solid, right? It's very closely packed. There is no in between space there, right? So this is how pressure can affect the particles of matter. Pressure can actually bring particles of matter closer together. Okay. Now the example for this is dry ice. You would have probably heard of it. Dry ice is solid carbon dioxide. Okay. Why do we call it as dry ice? Because solid carbon dioxide generally it is stored under high pressure conditions, right? If you bring it to regular pressure, that is 1 atmosphere, it will vaporize immediately. It will become gas, right? Sublimate. Basically, carbon dioxide is an example for sublimation. Dry carbon dioxide, it directly converts into gas without even considering the liquid state, right? So dry ice is stored under high pressure. When it is brought to the regular pressure, that is 1 atmosphere, it evaporates and becomes gas. So this is one example of pressure and how it is affecting the states of matter, right? Under high pressure, it's solid. When the pressure is decreased, it becomes gas. This is solid carbon dioxide, and we call it dry ice because it never converts to liquid. From solid, it directly goes to gas, right? So that is why we call it dry ice. Now, from what we have seen now, you can conclude that pressure and temperature both determine the state of a substance. You can change the state of the substance or state of matter by increasing or decreasing pressure or temperature. Both can be used to modulate the state of the substance. So solid, when it converts to liquid, that is what we call fusion. When liquid is converted back to solid, it is called solidification. Liquid to gas is called vaporization, and gas to liquid is called condensation. Gas to solid is called deposition, whereas solid to gas is what we call sublimation. So these are 6 terms that you have to remember: solid to liquid fusion, liquid to solid solidification, liquid to gas vaporization, gas to liquid condensation, solid to gas sublimation, and gas to solid deposition. I think these are quite simple. The words themselves, we mostly use them in our common language, right? So it's quite easy, I think. So I hope you remember these things. Now we are coming to the next topic and the last topic of this chapter, which is evaporation. So what exactly is evaporation? Before getting into the actual definition, let me just tell you the phenomenon that what we call as evaporation. So we have a collection of water, right? So let us say we have a china dish and we have some water in it. Now what generally happens is, particles of matter, they are continuously in motion. They are never at rest. Okay, this is what we know already. Particles of matter are continuously in motion. The thing is that some of these particles have really significantly more kinetic energy when compared to others. When some of these particles have more kinetic energy, it is easier for them to escape this current state and become more free. So in the picture that I have depicted here, you could see there are various levels of water. Basically what I am trying to tell is that there are some molecules, there are some matter, some particles that have very high kinetic energy. Okay, so these particles, it's easier for them to convert into gas, easier for them to vaporize, convert into vapors. So they can do this below the boiling point. So boiling point is where a bulk of water molecules become water vapor. That we have already learnt. Now below the boiling point, even below the boiling point, some of these molecules, because they have high kinetic energy, they get vaporized, they get converted into water vapor, and that is what we call as evaporation. So coming to the definition, phenomenon of change of liquid into vapors. So liquid is getting converted into vapors at any temperature below its boiling point is called evaporation. It can be nowhere as near as its boiling point and it can still evaporate, it can still convert into water vapors, and that is what we call evaporation. So one well-defined example that we use in our day-to-day life is drying your clothes. When you dry your clothes, you are not boiling it, you are not heating it actually, right? You try to put it in sun. Even if you don't have your clothes outside, inside your room you can hang it under a fan and it would get dried, right? We are not boiling it, we are not heating your clothes up, but they are getting dried. The water actually evaporates. How is that? Because they have higher kinetic energy. Some of these particles have higher kinetic energy and they absorb some heat from the surroundings as well. They absorb some heat from surroundings to help them free this state, to help them move from water to vapors. So basically what happens is, we have learned this already, to overcome the force of attraction you need energy. So these particles, they get heat energy from the surroundings, use that to overcome the force and become vapors. So this basically is evaporation. Now the factors that affect the rate of evaporation are surface area, temperature, humidity and wind speed. Now how exactly do these factors affect that? What we will see now. Surface area. Okay, now you would have seen that when you hang your clothes, you try to spread them out evenly. You try to make the area larger. You try to make the surface area that is visible to the sun or that is hanging, you try to make it larger. You don't just put it there. If you just put it there, it will take very long to dry up, right? But if you try to spread it out, it dries quicker, and that is what we call a surface area. So when the surface area is increased, it's easier for evaporation to happen. Over a large surface area, evaporation happens faster. Okay. The second thing is temperature. As you know, as temperature increases, the kinetic energy of these particles are increased. As more kinetic energy, as it gains more kinetic energy, it easily overcomes the intermolecular forces and becomes vapor. So higher temperature is an obvious answer. When temperature increases, obviously more kinetic energy, it's easier for the particles to overcome the forces and become vapors. The next thing is humidity. Humidity is the moisture content present in the air. If it's already saturated, if the air around you already has very high amounts of moisture in it, it's very hard for evaporation to happen. So that is why you see on a gloomy day, when the sun is very low or when there is high humidity in air, it takes longer for you to dry your clothes. Whereas in a sunny day or a day where humidity is very less, it dries quicker. Okay, so humidity is the amount of moisture content present in air. Lesser it is, more it is easier for these water particles or water molecules from our clothes to get inside the air. Okay, so that is how humidity affects this. The next thing is wind speed. So this wind speed is closely related to humidity. Why? So as wind speed increases, the humid air moves away. So you get fresh air which has less humidity, so it's easier for you to evaporate. So evaporation happens more easily. So that is how wind speed affects this. So what are the things that affect? First thing is surface area. More the surface area, evaporation happens faster. Temperature, more temperature means evaporation happens faster, directly proportional. Rate of evaporation is faster, higher. Humidity, more humidity, evaporation gets slow, so rate of evaporation decreases. Wind speed also is directly proportional to rate of evaporation. Okay, so as wind speed increases, evaporation is faster. Now these are the reasons, these are the factors that affect evaporation. Moving on, we are going to see how does evaporation actually cause cooling. Okay, so a couple of examples that we have already seen in our day-to-day life, right? You know acetone. Acetone is what we use in nail polish remover. You probably would have felt it in your hands, right? If you drop a drop of acetone in your hands, you will instantly feel that it's very cool. It's cooling to touch. It has a cooling effect. Why is that? Another example is, on a sunny day, we try to sprinkle water on our sunroofs. Okay, not exactly sunroofs, it's a car term. We try to sprinkle water on our roofs, right? Why are we doing that? We are doing that because the water particles there, it tries to absorb heat from our roof and it becomes as vapors. So this leaves a cooling effect, and the very same thing happens with acetone as well. It absorbs heat from your skin and turns into vapors. That is why you feel the cooling effect. So the definition or the technical way how you could tell this is, the particles of liquid absorb energy from surroundings to regain the energy lost during evaporation. So basically it means that these particles, they get energy from the surroundings and convert into vapors. This energy is used to overcome the intermolecular force of attraction, and that is why, since it gains energy from the surroundings, heat energy, the surroundings gets cooler. Okay, so this is why evaporation causes cooling. The next thing is, why should we wear cotton clothes in summer? We usually prefer cotton clothes in summer, right? Why is that? In summer we sweat a lot. Perspire is just a fancy way of telling that we sweat. Okay, so don't get worried by that word. So in summer we sweat a lot, and cotton is generally a good absorber. So cotton absorbs our sweat and thereby increasing the surface area and exposing this moisture content to the sun, right? Since the surface area is higher, it gets evaporated easily. Since the cotton cloth, it absorbs it and makes it available for evaporation quickly. Cotton has a high rate of absorption. It can absorb so much. Okay, so that is why we generally wear cotton clothes. Why do we exactly sweat a lot in summer? Because that is the way our body uses water to keep our body cool. Okay, so that is why we sweat a lot, and cotton is generally a good absorber, so it absorbs all the sweat and it helps in evaporation. The next thing is that, why do we see water droplets on the outside surface of glass containing ice cold water? So when you take ice cold water from the refrigerator and keep it outside, you will instantaneously notice that the outside walls have water droplets. Why is that? So the outside air, it has water vapor in it, obviously, and since it comes in contact with this cold tumbler, what will happen is that it absorbs the cold tumbler. Since it's cold, it can easily absorb heat energy, right? So energy flows basically from higher point to lower point. The water vapor that is present in air has higher heat energy when compared to the surface of the tumbler. So the heat energy passes from the water vapor to the tumbler. So since the energy has been passed out, it converts from gas to liquid instantaneously. Since it loses energy, obviously gas has higher energy when compared to liquid, right? Since it loses energy, it gets converted into liquid, and that is why it appears as water droplets. So the water vapor that is present in the air, since it loses energy to the tumbler, to the glass, it becomes water droplets in the surface of the glass. So that is all that we have seen in this episode. If you have any questions, please let me know in the comments and I'll get back to you as soon as possible. I hope you liked this video. If you didn't understand anything, or if you felt something is difficult, or if you have any suggestions, please put them in the comments and I'll get back to you. Thank you so much for watching this video. See you in the next one. Bye for now.